Hey everyone, and welcome back to the Properties of Geometric Figures video series. In this video we are going to focus on similarity with triangles. Now you can see there in the little blurb we're saying that two objects are similar if they are of the same shape, but they can be of a different size. It's how computer images are reproduced. It is also how photos can be enlarged, paintings, it's scientific diagrams, all sorts of things can be enlarged or made smaller based on similarity. Now, a quick little definition of similarity is when two shapes or two or more shapes the same shape, but not necessarily the same size. But have matching angles, and so have matching angles. But have matching angles or matching angle pairs that are equal and matching sides. Now these guys aren't going to be equal, they are going to be in the same ratio. So this is where we're going all the way back to ratios and understanding how ratios work in a similar fashion to fractions. Now, just like with congruent triangles, we can have statements around similarity. Now, in congruency, we have the three lines that are horizontal. That is our congruency symbol. And for similarity, we actually use vertical lines. So the vertical lines are for similarity, the horizontal lines are for congruency. So one example of a similarity statement is, say we have triangle ABC, and we want to say it is similar to triangle DEF. So that's how we would do it. Put the triangle symbol, use our vertical lines to indicate similarity. Now, just like in congruency, similar triangles have some tests that are available. Now, they don't have official names, but we do seem to match up quite nicely with the old congruency ones, just they don't have the same exact names. Now, the first one there is all about the angles of the triangle. So this one's all about the angles. Alright, so what it's saying is that if two angles of a triangle are equal to two angles of another triangle, they must be the same. So then we have similarity. So if two angles in one triangle are equal or are the same as two angles in a second triangle, they are similar. And they kind of have to be, because that third angle must be equal as well. Now, the second test that you can see there is all about the sides. So we want three sides that are in proportion to the three sides of another triangle. Okay, so we want those three sides all to be in the same fashion. So if we matched up 6 and 3, so 6 over 3, and then we could have that be the same as 4 over 2, which would be then the same as 2 over 1, which just equals 2. So it's all in the same proportion. Now the third one there is looking at two sides and the included angle. So we need two sides in proportion and the included angle to be equal, and then that would indicate similarity. And then our last one there is the right angled triangle one. So we want the hypotenuse. Alright, and another or a second side to be in proportion. So that's what we were talking a little bit before, because obviously the right angle is going to have the same value. Okay, now while we're doing this, as you can see up here, you might not be able to see that 2 anymore. Let's make that black. Okay, so that little 2 then becomes our scale factor. So scale factor is the next idea that we are looking at, and the scale factor is calculated using a pair of corresponding sides. Okay, so that becomes the number. So this is the number that you either multiply or divide by to either enlarge or reduce, because you can go both ways. Okay, so that's scale factor. Pretty quick and easy. Let's jump into a couple of quick examples and crack on with some questions. Alright, so prove that the pairs of triangles are similar. So here we go. We have angle A over here is 70 degrees. Angle D over here is 70 degrees. Angle B is 30. Angle E is also 30. Now what we know from our tests, if two angles are equal, or two matching pairs of angles are equal, we are good. So angle BAC is equal to angle EDF. So remember that the center letter in that set has to be the vertex where the actual angle sits. And then we give our reason. So that's given in the diagram. Then angle ABC is angle to DEF, again keeping our angles in the middle. That is also given. Therefore, triangle ABC is in fact similar to triangle DEF because matching angles are equal. So this is part of what we're doing with proofs. It is actually just stating information from the diagram with a reason as to why it's true. Let's look at our second one there. We've got A, B, C, and D, E, F again. A little bit different this time though. Alright, so got my trusty purple pen. Let's look at side AB. Side AB. And let's find its matching side would be side DE. Okay. It's equal to 5/10. Now, we actually normally go the other way around and have the bigger side on top, but that's okay. So that's going to be a half. In fact, we might do that because that's going to be a little bit easier to do. So let's put the bigger numbers on the top. So let's go DE. Let's do the second triangle first. Alright, so that's going to become 10/5, which is 2. And then we're going to look at, let's say, EF. EF, and it matches up pretty nicely with BC. And that's going to be 16/8. And lo and behold, that is also 2. Then we have our final side, which is going to be DF over E or BC, or is it AC? I think it's AC. Because we've already used BC, so it must be AC. Alright, and that's going to be 14/7, which again is 2. Therefore, triangle ABC is similar, let's move that up, to triangle DEF, and the reason is matching sides are in proportion. Okay, so it's about pulling that information out and matching it all up. Alright, last question, last example. The given triangles are known to be similar, so we already know that they're similar triangles. We now want to know the value of x. So if we look at line DE, and it matches up with the line AB, so that equals 4/2, which equals 2. That's our scale factor. Okay, so if our scale factor is 2, we want to multiply 3 by 2 to get x. X equals 3 times 2, so we multiply it by our scale factor, okay, we're going to multiply by that scale factor to give 6, so x equals 6 in this problem. That's it, that's all there is to it. Good luck with those questions, ladies and gents, and I'll see you in the next video.